We've got a story that involves customization, iteration, advanced materials,
and a very cute dog, all on this episode of The Cool Part Show. This episode of The Cool Part Show is brought to you by Carpenter Additive. The company's Powder Life solution is a combination of hardware and software technologies designed to help AM users manage their metal powders. Stay tuned after the episode for more on how the system works.
I'm Pete.
I'm Stephanie.
Welcome to The Cool Parts Show.
This is a special episode of The Cool Parts Show featuring one of the winners of the Cool Parts Showcase, our first ever contest, which we ran in 2021. The part that we're going to talk about today was the winner in the Bespoke Solutions category, so something that was made for a specific, unique challenge.
The Cool Parts Showcase, and I remember this part. I remember the special bespoke purpose it was made for. This is a dog wheelchair. It is a wheelchair made for a special individual dog, an Instagram famous dog named Wobbly Hannah. She has a neurological condition, makes it hard to walk, hard to control her motions. She needed the help of this special customized wheelchair. It was made through 3D printing by a very talented engineering team. So this is a design story, it is a product development story. As we're going to find out, it's a materials story.
Absolutely. So it's not just about a cute dog, even though she's extremely adorable. We're going to get into some serious issues with 3D printing, with manufacturing. But I think maybe the cute dog is the place to start. We should just talk about Hannah for a little bit. So Hannah has this condition, cerebellar hypoplasia, which affects the way that she moves, which means she needs a wheelchair like this. And we should be clear here at the beginning, this is not literally Hannah's wheelchair. This is a copy. She has the original. We definitely did not take it from her.
No animals were harmed in the making of the Cool Parts Show. So, just as you say, let's talk to Hannah's owner. This is Cassidy Drupal.
We adopted Hannah in November of 2019. We had a full house that we had no intentions of adopting another dog, let alone a special needs dog at that. Happened to see a rescue out of Wisconsin post Hannah and her story, and that she didn't have anybody applying to adopt her, and she was about to turn 3 years old. And after about a month, she didn't have any applicants still. And so we just kind of knew, that we were going to make it work and that she was going to come home with us as long as, we were approved to adopt her. It just kind of happened, and we weren't planning for it in any way. And I don't think we could have planned for it in any way. So cerebellar hypoplasia is a neurological condition where your cerebellum isn't fully developed, which is the portion of your brain that controls like your fine motor movements, your balance, your coordination, kind of feeling where your body's at in space. She was born with it, so it's all she's ever known. Her cerebellum is just underdeveloped, so it's kind of like her muscles and her nerves don't like speak to each other and communicate very well. So it's just kind of all over the place, like looks like clumsiness essentially, which we can all relate to, but she just has it all the time.
So Cassidy just sort of kind of described the way that Hannah moves, and they have tried a number of other assistive devices with her, different slings, different carts and wheelchairs. But Hannah's case is actually a pretty severe case of cerebellar hypoplasia, and so the way that she moves is really unpredictable, and that presents some challenges. The other thing is that, as we learned from Cassidy, Hannah has this big personality. She has a little bit of an attitude, and if she doesn't like something, like she's just not going to go along with it. And so they tried these other solutions, things, sort of worked, sort of helped in different ways, but they never really found just the right thing. And then Cassidy saw something on Instagram. She saw this company that was doing something a little bit different that she thought might work for Hannah.
We have tried wheelchairs and just mobility devices and supports nonstop, I would say, since we've adopted her. That's just with her impacted mobility being so severe, it's something we're constantly having to do. We tried some custom devices that were made for her based on her size. And a lot of times the issue was the stability and the safety of the carts with Hannah in it, just because she does need so much support. She's essentially always falling in her chair, and the chair kind of has to catch her. So it has to support her full body weight, which is 65 pounds. And it also has to allow her to move. And sometimes the motion is difficult too, because it's not like your standard motion where a dog knows, right, left, right, left. It's, it might be back legs crossing, front legs crossing, So we randomly saw Dive Design post a video. I think it was of a dog that was wearing one of their jackets, like very fitted jackets, and it intrigued me. It intrigued me because it seemed so stable yet customized, and that's where it started. It was just me happened to see something on Instagram. I messaged them. They got back to me right away, wanted to set up a video call. And from there, we just kept things rolling, and they were really excited about getting the chance to work on it.
So, Dive Design, New Jersey-based engineering firm. They have some experience with animal prosthetics, animal assistive devices, and in fact, these products are great applications for 3D printing, as they discovered in their experience with, for example, bionic pets. This is Alex Thole. He's the CEO of Dive Design.
We got hooked up with Derek Campana, who is the CEO and founder of Bionic Pets. They're one of the nation's leading animal prosthetics and orthotics clinic. He was showing us around. He was showing us how he builds the prosthetics, some of the challenges he faces, which were, moderate. And then he had shown us what he called the full limb prosthetic that he had developed. And we're like, this is incredible. He goes, the problem is there's a huge opportunity for them. There's a huge demand, but it takes me 15 hours to build just one. It's extremely time intensive and it's labor intensive, not only by me, but my crew, and materials intensive. So wasting a ton of plaster of Paris, a lot of wasted thermoformed plastic, etc. And so, of course, the wheels started turning. We had generated a 3D printable prosthetic over the course of 6 months. We developed it using a 3D scanning of the dog's fiberglass mold, using a custom design script that we developed alongside a good friend of ours, and of course 3D printing here on very basic FDM machines. So we've known about cerebellar hypoplasia, which is what Wobbly Hannah has. We never really had an opportunity to address it. We had been dabbling in carts, helping oddball cases where we could. Wobbly Hannah's owner, Cassidy, had reached out to us over Instagram about 6 months ago now, and had asked if we could potentially help her come up with a solution for an ongoing problem they had.
So even though Dive had experience building devices for other kinds of pets and animals, Hannah's case was unique because they'd never dealt with this condition before. So the jacket that originally caught Cassidy's attention, that proved to be really important to making this cart work for Hannah. But there were a lot of other design considerations, a lot of other things they had to figure out. And so 3D printing played a role for the customization, but also for that rapid iteration process as they were trying to work these things out.
So if you notice in our other wheelchairs, they're all sling type setups where they sling underneath her armpits, her stomach, and her hind legs. And the problem with that is the connecting point is at the top of this cart, meaning that if she's to topple over, the connectors are at the top. And so she's going to go over a lot easier because it's a higher center of gravity. What we did is we connected her basically at the lowest possible point. We used one of our jackets that we design, these flexible TPU jackets, and we have our base mounting system, and that got mounted to the lower part of this cart, and therefore we're reducing and lowering her center of gravity. We also, because the sling works so well for her, because she is constantly swinging left and right, we added that sling to the rear to hold her rear end up. Whereas with the front, we're harnessing the power of her rib cage, not only to give it structure, but to prevent her from slamming left and right into the carts like she does with some of the others that she's tried. We noticed with all the other wheelchairs she had that they were lining up the front wheels with her front legs. Obviously, that's going to create the pivot point right there where her front legs are. And so she's got a lot easier of a chance to fall forward, which was very visible in a lot of the clips that we had, and one of the biggest pain points Cassidy had shared with us. And so the very simple solution to that was moving the wheels ahead of her, putting them at the tip of her nose rather than behind her nose. And now she has zero chance, and if at any, it's extremely low, of tipping forward.
So this was a materials challenge too. This wheelchair, the structure of it needs to be lightweight so that it's nimble, can move easily, but it needs to be strong too, stable. Hannah's a big dog. This is a heavy animal. The 3D printing process was FDM, fused deposition modeling, also known as FFF, fused filament fabrication, but extruded polymer. And the material that proved successful here was a carbon fiber reinforced polypropylene. It gave that combination of strength plus lightweight. The material came from Braskem. Let's bring in one more voice here. This is Jason Vagnazzi. He is commercial director of additive manufacturing for Braskem.
We love this material for the Wobbly Hannah project for a few reasons. One, it's lightweight. Second is strength. That carbon fiber provides the right balance of tensile strength and impact strength, and it's really made to withstand anything that Hannah can throw at it as she's running around out there enjoying life. The last piece, with polypropylene is it retains 98% of its material properties in temperatures below zero. So you wouldn't have to worry about this material becoming brittle in those winter months while Hannah's outside enjoying herself. Maybe one final aspect I want to note with polypropylene is polypropylene is naturally chemical resistant. You can just take some bleach, you can take any disinfectant off the shelf, you can hose it down, you can wipe it down, and you don't have to worry about those chemicals, those harsh chemicals, degrading the performance of that material over time. Polypropylene is going to stand up really well to that.
So as Braskem was getting ready to launch this carbon fiber reinforced polypropylene, they were looking for users, they were looking for good test cases for this. And Jason, again, connected with Dive Design over Instagram, reached out, they started to try and figure out how they might work together. And it's about the same time that Dive is starting to work on this project for Hannah. And together they figure out that this material might be something that works for this wheelchair. So we have the material, we have the printing process, we have the dog. Are we ready to talk about how all of this comes together into this wheelchair?
So I am so ready, and I think we should stress, there's real geographic distance here. Dive Design is in New Jersey, Cassidy and Hannah live in Nebraska.
Right, and the world is kind of locked down during the time that this is all happening, so travel is not the easiest thing to do.
So early on, you mentioned this harness and the way that it's customized to Hannah's body, customized to this individual animal. Because of that geographic distance, combined with some challenges of working with Hannah, Dive could not use its normal method for discovering the geometry of the animal. They had to get it a different way.
I think both sides understood in making this cart for Hannah, we were going to have to do some things differently. And that started right away from the beginning when, so they wanted to send us a mold kit. So a mold kit, essentially she would have to be standing completely still. And as we've talked about, Hannah can't do those things on her own. And she's also very stubborn and resistant. So trying to even have someone else help hold her as I was going to try and do this, it just wasn't working. And I found out quickly. And so that's when we had to move to option B, which was like downloading an app that you can do like a 3D scan essentially. I downloaded that and then I just put her in the cart, which doesn't do per se a scan of just her body, but we were able to make it work with multiple scans. We just made it work and took it one step at a time.
So Dive gets this scan data. They have to start doing all this design work. They're on video calls with Cassidy, they're iterating, they're printing lots of prototypes. At the same time, they're also iterating all this stuff with this material, trying to figure out the right print parameters for the polypropylene as well.
We're very well known for pushing things to its limits and then past it to the point where we break our printers constantly because we're really trying to push the boundaries. We pushed Braskem's filament really to the speed test, which was really exciting. We pushed it to the temperature test to see really what the true range of it was. And that's really how we find out about speed as well. What temperature can we really crank this up to really get the speed that we're looking for? Because in the back of our heads constantly, it's like, how does this really become a manufacturable part? How is this not just a one-off? And it comes down to speed. It comes down to the design flexibility. And so to us, it's always in the back of our heads to push these materials to their limits.
This was one of the first real world applications that we had for this material. When you're developing this material in a lab, you tend to be a little bit conservative on the performance claims as well as the processing conditions. When we handed it over to an entrepreneurial company like Dive, they pushed the limits all around. They did some stuff with the material that if they asked us up front, we probably would have said no. The printing speeds, they essentially doubled the printing speeds of what we initially recommended. So, working with them, having them push the limits really opened our eyes to what the possibilities could be for this material and what some future applications are.
First real world application, and it worked. Now we should say work in progress. They're continuing to iterate. They're still refining the design, but the really amazing thing is how well it worked, given that the actual physical performance field test couldn't happen until the very first day that Dive Design met Hannah. So the Dive Design team, the engineers there, they are working on this challenge. They are refining the design. They are iterating. They're making changes big and small, and they get to a point where they think they've got it right. And the proof happens when they get on a plane and fly to Nebraska.
It was nerve-wracking. We were extremely anxious because anything that we do, we always want to test. And for us to say we're flying out to Nebraska, it almost has to work when we get out there, is very tough for us as industrial designers to comprehend.
That was a really cool part of all of this. So they actually took it upon themselves to fly out, from New Jersey to Nebraska, which was, I'm sure, a really fun vacation for them. Come to our house, meet Hannah, see really in person what Hannah is like, and why this unique wheelchair was so needed, and the specific things that we were asking for. So then they came out, they put it all together, we got her in it.
So when we got out there, we had to make a few modifications. We had to raise her up a little bit. We brought blocks with us, TPU blocks that we can adjust height with. So that was great. We needed those. I needed longer bolts for the rear wheels, which we had to change out. The jacket we had sent out 2 weeks prior to make sure it fit properly, because that's like the biggest thing we have to check. And it did, and it fit great. So that meant that her scan was really quite accurate, and that Adam's mesh mixer sculpting skills were great too.
And what was really cool about them being here was that even when we got it together and got her in it for the first time, we were able to make some adjustments kind of even on the spot, on the fly, because everyone was here. There's a hardware store down the street. So that was really cool. And just making some even just initial adjustments, small things, but important things for Hannah.
So it is pretty amazing how far Dive was able to get using a smartphone scan and these video calls and all that. But getting physically there with Hannah, there were some adjustments that had to be made, and that adjustment process is still ongoing. They're still making tweaks. They're still trying to make improvements to this chair to make it the best possible solution for Hannah.
We're still working on getting everything right. So it's really cool from afar that we can do like video chats and adjustments and stuff, but it's actually a little more difficult to do that now that we kind of have the main piece and are working on like small adjustments, because we have to do one thing at a time, one small thing at a time. We can't change multiple things and not know what impact they're having. So right now, we're using the wheelchair. I get her in and out of it for short periods a day as I kind of take some videos, make some notes as far as like what I feel like is affecting her. And we're still working from that prototype on some new pieces and parts that will ultimately make the final wheelchair. But going into this process, I knew it wasn't going to be a one and done. And I don't think it's possible with a dog like Hannah to just make one thing right out the gate and have it be perfect. I really don't. And I was expecting that. So we're still working on perfecting it. They took everything that we wanted, and you can see it in the cart. So that's the most promising part of it all. The wheels are further out for her so that, her paws don't get run over. The material, it's all there. So we just have to figure out now kind of the details of it, and and what that looks like for Hannah as far as a final product goes.
They're still refining the design, but because it's 3D printing, that rapid iteration that Alex referred to, it can keep right on going. This design is still improving. Cassidy is still receiving changed, slightly tweaked components, and this wheelchair is getting better and better.
We should also say that while we've been talking about this specific chair for this one specific dog, DITIVE sees a way that the work that they're doing right now could be applied to other animals. So as we talked about at the beginning, like this jacket, the really custom part is kind of the key to making the chair work for each individual animal. But the rest of the wheelchair could be sort of standardized, kind of modular. You could adjust it, adjust the height, different parameters for specific dogs and not have to start over in the future. So DITIVE sees this as a potential solution for Hannah, but also for other dogs, maybe other animals in the future too.
All right, I think we got this. You want to start?
Sure. So this is a custom wheelchair for Wobbly Hannah, an Instagram famous dog who is affected by something called cerebellar hypoplasia, which affects the way that she moves and her mobility. Her owner Cassidy had tried a number of other wheelchairs, different devices with her. They all had different challenges. Some of them allowed Hannah to fall forward or they ran over her feet. And so they were sort of searching for the right solution, and Cassidy happened to see this company, DITIVE Design, through Instagram that was doing something different.
So DITIVE Design took this on, and they realized, in Hannah's case, the center of gravity should be lower, and the front wheels should be farther forward. 3D printing, using 3D printing to make all of the components, just about all the components of the wheelchair, let them test all these ideas and refine these ideas and iterate. 3D printing also proved significant because it allowed them to use a material that proved important.
Right, so the main body of the wheelchair is made from carbon fiber reinforced polypropylene. This is a new material developed by Braskem, and DITIVE had to iterate on the print parameters at the same time that they were doing all of this design iteration. But the solution that they came up with works. They were able to take it out to Nebraska to fit it to Hannah. They are still in the process of refining and finessing this solution, but this is a device that's going to be transformative to Hannah, could also potentially be used, a similar device could be used for other animals in the future as well.
All right, I think that'll do it. If you're finding us for the first time, welcome to the Cool Parts Show. We have lots of other episodes about the ways that 3D printing is changing things. It is helping spacecraft, it's helping cars, it is helping consumer products, things we wear, it's even helping animals. This is not our first animal episode. We did an episode about meerkats. Check it all out at thecoolpartsshow.com.
If you like the show, we hope you'll subscribe, leave us a like, leave us a comment, share this episode with an animal lover or just somebody who's into 3D printing. Thanks for watching. Thanks again to our sponsor, Carpenter Additive. In addition to supplying metal powders, the company also offers services, software, and hardware to help AM users manage their powder. One example is the Powder Life System, a combination of cloud-based tracking software with hardware designed to make powder handling easier. Two key components are the Powder Life Hopper and the automated docking station. Luke Boyer, manager of Powder Life Applications, and Andrew Holliday, applications engineer, explained how the system works.
So today, when a user of additive manufacturing is receiving powder, they oftentimes receive it in either 5, 10, 15, maybe a 20 kilo bottle. But they're receiving pallets of them, and you're receiving 10, 20, 50, hundreds of these bottles. The user has to look and segregate and store them appropriately so the bottles don't get mixed up. And it requires a lot of lifting and moving and labor.
The components of Powder Life are all based around making powder management systems on the additive manufacturing shop floor easier to use for the operator, cleaner, as well as more traceable. 3 of those basic parts of Powder Life are our Powder Life hoppers, or our storage containers for powder. The second would be automated docking systems that allow material to be pushed in and out of machines with no human contact. And the third would be our Powder Life online software system that allows you to trace this powder as it goes through your shop floor.
The hardware, the software together just helps really streamline that and improve the final user's experience and let them concentrate on going from design to the part itself. Takes the headache of powder management out of the equation for them.